Our topic today is: Has analytics changed how we do quality? Now, I've already heard this presentation, and I really loved it. I was telling Dave this the other day. Uh, I think you're going to find this. I know you're going to find this a great presentation. It's caught a lot of interest with me, and it hit home. Dave Northcutt is a ASQ certified quality engineer, Inform certified analytics professional. He's been 35 years as a retired. Well, he's a retired industrial statistician, 35 years of experience in the IT industry, and was an IBM distinguished engineer, specializing in data analysis, predictive modeling, and continual improvement in IBM services business. And with that, Dave, I think you can grab the. I'm going to mute everybody. If you've got any questions, line them up in the chat, and we'll take them. In fact, point the chat to me, and I'll have that discussion with Dave on the any questions. So with that, Dave, I'm going to turn this over to you, and people continue to join. Go ahead.
All right, very good. Thank you, John. Can you see my screen now? I've shared it.
Oh yeah.
Okay, good, good. Then I think things are working, which is what we want. So, good afternoon, everyone, and thank you for having me. I appreciate the opportunity. As John said, today's topic is: Has the analytics wave changed how we do quality? Um, it's not too surprising. I think that this question comes up fairly often. Uh, I'm sure all of you have heard a lot of talk about analytics over the last several years. It's become quite a hot topic. And so what I'm going to do a little bit is talk about, what does that mean? What does it mean for quality? And let's just jump right in. So this is the agenda I'm planning to follow today. We're going to talk a little bit about what is analytics anyway. I'm going to set a definition. It's not the only possible definition, but I think it's a good solid one, and it'll guide the rest of the discussion. We're going to talk a little bit about the history of analytics and quality. Talk a little bit about where analytics came from. That could be a week-long discussion in and of itself, but we're going to make a quick flyby. Talk a little bit about what's new and why we're hearing so much about it now. Why is this all of a sudden a hot topic? We're going to talk a bit about the benefits and pitfalls of the analytics movement. We're going to talk about data presentation, and then we'll wrap up talking a little bit about how to keep pace with your career. So, what is analytics anyway? So, I started out just by going to the dictionary, and this is what Merriam-Webster said: that analytics is the method of logical analysis. Can't really disagree with that. It's a nice definition. It seems a little broad for what we're trying to do here today. It could encompass an awful lot of different topics that we're not going to talk about. So I looked a little bit more, looked in the Oxford Advanced Learners Dictionary, and it says that analytics is a careful and complete analysis of data using a model. Well, I like that right off the bat, that it talked about careful and complete analysis. Uh, as we'll see as we go along a little bit here, that's not always the case with some of the analytics we see today. I also like the fact that it talks about using a model, and we're going to talk about that at some length. Usually performed by a computer. As it turns out, that's going to be a big key as to why all of a sudden this has become so popular. And then it's also referred to as can also refer to the information resulting from this analysis. And we also tend to use that term that way a lot. Is analytics is the output or the result that we get. I'm going to use a definition from Informs. This is the Institute for Operations Research and the Management Sciences. They've been around for quite a long time. Some of you may be familiar with them. They have what I would argue is probably the leading analytics certification process in the world right now. And their definition is the scientific process of transforming data into insight for making better decisions. And I really like this definition because to me, this is exactly why we do analysis. I would argue that none of us on this call is doing analysis just for the pure joy and beauty of it. We almost all have some end goal we're trying to achieve, usually making a better decision. It could be in any number of different fields, but usually the whole point of the analysis is to get to a better decision. Informs has a fairly sophisticated model around this. They describe three different types of analytics. At the bottom of this chart is what they call descriptive analytics, and they term this "what happened." And this is all the standard stuff that I think we're all pretty familiar with: reporting, visualization, data modeling. When people think of statistics, this is what most people tend to think of: is means, medians, modes, all that kind of good stuff. Identifying patterns from samples, reporting trends, looking at historical data. Though this is when you talk descriptive, you're talking about looking back in time. The next level of sophistication that they have is what they call predictive analytics. And this has to do with forecasting. Much of the forecasting from doing statistical or simulation work, but also from data mining and pattern recognition as well. And the whole idea is to predict future outcomes, future probabilities and trends based on relationships that have been discovered in the data. And then finally, at the top of this hierarchy, they define what's called prescriptive statistics. In other words, what should we do? The idea of how do we take action to take control of what we've described and our ability to predict, then we can put those together and start to make decisions. And this is where you get into the whole field of optimization, which is one of the key aspects of the Informs organization. Operations research is really about doing optimization for a very big part. It targets business objectives, and the idea here is to also balance the constraints. As I'm sure you all realize, being in business world, finding optimal solutions is a piece of cake if you don't have any constraints. But we usually lack unlimited time and resources, and so we have to make what we call constrained optimization choices. So given that I only have X thousand dollars to spend on this project, where do I spend it best? Where do I get the biggest bang for the buck? Those are the kind of questions that optimization can answer. So this definition actually comes from the Informs body of knowledge. It's a book that was published just a few years ago, actually, when they started to really codify this around the whole certified analytics professional certification process. So that reference is there, and it's available both online through Kindle or in hard copy. Well, it turns out we've been using analytics and quality since at least the 1920s. This picture on the right, which I'm sure most of you have seen, certainly if you've been to any of our seminars, you've probably seen these a number of times. This is what's known as a statistical process control chart. And a gentleman by the name of Walter Schuhart, who was then at AT&T's very new Bell Laboratories, invented this concept back in the 1920s. And the whole point of an SPC chart is to allow us to differentiate between what's called common cause, or causes caused by chance, and special cause or assignable cause variation. And the idea quickly behind the SPC chart is that any movement inside the red lines is what's known as common cause variation. Any movement outside is known as special cause variation. And the difference between these two is really the key to any successful quality initiative. This is probably one of the biggest mistakes I see quality efforts taking, is they don't quantify the source of the variation before they begin. And what that tends to do is it leads you to a pattern that says, well, every time the data moves, I need to find some explanation. Well, as it turns out, as you can see, this particular data set has quite a bit of movement in it, but none of it is what I would call assignable cause or special cause. So in other words, asking what happened between the third and fourth data point to cause this to go up is essentially a waste of effort because that movement is consistent with the overall amount of movement that this data has exhibited. 24 data points here. There's lots of data. Uh, there's no reason to believe that these limits aren't an accurate description of what this process entails. So this was a huge breakthrough in the 20s. One of the problems Schuhart was working on was AT&T had just started burying telephone equipment underground. And what they discovered was that most of the time they buried it and it worked great. And sometimes they buried it and they were digging it back up a week later, a month later, a year later, whatever. It wasn't lasting like they had expected it to. And Schuhart was charged with solving this problem. And in the process, he invented statistical process control. And he was able to separate the noise from the signals. And that's really what this is all about. Anything inside the red lines is noise, and anything outside is a true signal. And by being able to do this, he was able to focus the effort appropriately. The quality movement built on this after the 20s. His charts were used to improve production during World War II, especially. It really took off. There were numerous other techniques adopted over the years as well. But this was kind of a benchmark discovery in the quality field. Major names in quality were also leaders in using analytics. So the people like Deming, Duran, Taguchi, Ishikawa. Quality has been known for its analytical approach for a long time. So some examples of analytics used in the quality arena, and I'm not going to go through all these in detail here because it's a rather large list, but you can see I've got statistical process control on there. Process capability, which is similar to statistical process control, but it allows us to look at how does our process performance compare with the actual specifications as required by the customer or the end user of the process itself. Sampling methods, a big part of all of this. And you can see a number of things here. I'm sure most of these items ring bells for most of you out there. Design of experiments is a big topic. We're not going to talk about that tonight or today. It's not nighttime yet, right? We're not going to talk about that today, but it's an area that's been used extensively to help improve processes. I just gave the talk about that last month for the ASQ group in Dayton, Ohio. And so lots of different things here. You may be wondering, well, where did all these come from? I actually got this list from the ASQ Certified Quality Engineer body of knowledge. So these are all things that are required of a certified quality engineer. You need to have capability in all of these areas because these are all important aspects of doing quality analysis at one time or another. Now, I've never done a quality improvement effort where I used every one of these tools on the same effort. It's just not the way it works. Some things work better in different situations, and that's part of what having the experience and the skill is knowing when to use which tools. So where did analytics come from? Well, we saw that Schuhart brought up some things in the 20s that certainly would qualify as analytics, but we've been doing analytics for a long time, centuries, but it just never got called that. This is a very brief list. We're gonna zoom through about 2,000 years of history here, but the Greeks were probably the first to really do what we would today call analytics. A lot of the work in geometry was nothing but pure analytics. It didn't initiate out of some, well, let's sit down and play with formulas and see what we can find. It probably all initiated out of, we're seeing this pattern when we make a triangle. we've discovered this relationship between the two legs in the hypotenuse. And it eventually came down to the Pythagorean theorem. It's almost guaranteed that they didn't come up with the theorem first and then start using it in their day-to-day work. It was the other way around. That's real-world analytics. So we move ahead about 2,000 years here. Another major analytics accomplishment was by Thomas Bayes, and that's the Bayes theorem of conditional probability. Some of you may be familiar with this. This may be something new to others, but conditional probability is a huge aspect of analytics, and this is probably the second area where I see an awful lot of mistakes being made. Conditional probability simply means taking into account what has already occurred when you ascertain the probability of some future event. So, for example, let's say you're flipping coins. Let's keep this real simple. And you say, well, what are the chances that I flip 4 heads in a row? Well, I think we could all figure that. That's 1/2 times 1/2 times 1/2 times 1/2, which is 1 out of 16. All right. So you would expect that would only happen one time out of 16 on average over the long haul. But if I've already flipped 3 coins and they're all heads, what are the chances of having 4 heads in a row given that I've already got 3 in a row? Well, that's a very different problem, and it turns out the probability of that is simply 1/2, because you have a 50% chance of getting another head and a 50% chance of getting a tail. So conditional probabilities can have a huge impact on how we look at things. This is huge in the area of medicines, because this has to do with how we look at things like, what's the probability that you have the disease given that you tested positive for it? And interestingly enough, it's almost never the probability that you would expect it to be from a test that, say, has a 95% uh, uh, success rate or a 95% accuracy rate, let's say. Why is this important? Well, I think we've all just lived through why that's important for the last 14 or so months. Tests that have high accuracy rates can still yield fairly high false positive rates depending on a number of factors. Being able to understand Bayes' theorem and conditional probability is critical to getting good analyses for that. Just as a side note, we have a lecture tonight from our ASQ chapter by a gentleman who's done a lot of analysis on the COVID data. And so I'm just dying to see what he has to say, and I suspect that Bayes' theorem will come up there. If you're interested, signups are still available right up until the minute it starts, actually until the minute it ends, to be honest. And our website, asqmidhudson.org, if you go there and go to the current events section, or to our PDM section, you're more than welcome to sign up. It's free. He's going to talk about data analysis around the COVID issues, so it should be fascinating. We'll buzz through here the next few here. Adrian Legendre, least squares. This is the whole theory behind doing regression analysis. It's been known since 1805. All right, so a tool that we use a lot has been around for over 200 years. Analysis of variance and design of experiments. This was another huge breakthrough. R.A. Fisher did a lot of this work in the late teens and early 1920s that have allowed us to do designed experiments and all the things that you probably hated in statistics class, like F-tests and T-tests, stuff like that. Fisher was instrumental in a lot of that. In fact, the F-test is named after him. That's what the F stands for, is Fisher. So, again, been around a long time. Walter Schuhart, we've already talked about. Danzig, the simplex method for linear programming. This is where computers have helped us tremendously. it was really hard to do optimization and linear programming for many years. Danzig's method made it possible, but it still didn't allow us to scale to huge problems because it was just very computationally complex. That's all changed, and we'll talk about that in a little bit. Marvin Minsky, neural networks. Folks think that machine learning is new and artificial intelligence is new. Minsky invented neural networks way back in the early 50s. Actually, did most of the work in the late 40s. So again, not a lot of new stuff under the sun here. And finally, Harry Markowitz, the efficient frontier concept, basically building on some of the work around linear programming and simplex method to understand that there's an efficient frontier. There are an equal number, oftentimes, of efficient points to produce, and it really depends on other issues that you may want to consider. But from a pure optimization standpoint, we often end up with more than one point, and that's known as the efficient frontier. So, with all that history, you might be asking, well, so what's new, right? Because that seems to cover a lot. Well, there's a lot new. And one of the first things that's new is that massive increases in computing power, network bandwidth, storage have made previously intractable problems seem easy today. Any of you that have done anything in the area of computer security know that the lengths of keys have been going up constantly. It used to be, you had a 32-bit key. It was uncrackable, right? And now most PCs can crack a 32-bit key in a matter of seconds. A lot of things are up to 256-bit keys. We'll be at 512 eventually, I'm sure, without too much time. The point is that all this speed and capacity have allowed us to solve problems that we couldn't even think of even 15 years ago. And that's made a huge difference. And so we're able to tackle things that we couldn't have tackled not that long ago. Another thing is machine learning. In spite of the fact that Minsky did a lot of work in the 50s, this has continued to grow and improve. Lots of different algorithms and methods to improve in all the areas, actually, descriptive, predictive, and prescriptive in real world context. This has been growing at a very fast pace, and machine learning continues to grow by leaps and bounds. So this is another new thing. Big data, which is really new. I can remember when if you had a data set with 10,000 entries, you were busy trying to figure out how you were going to deal with it. Could you break it up? Could you do different things like that? Well, 10,000 entries is nothing to Excel. In fact, the latest versions of Excel can literally handle hundreds of thousands of rows without any problem at all. And now we're talking about distributed data sets. Some of the data being here, some of it being in Singapore, some of it being in Germany, just all over the world. And we now have algorithms that allow us to look at data in different places and do the analysis. It's pretty amazing what's happened. As you can imagine, that's changed how we can look at things tremendously. Unstructured data is also an area that's grown a lot. It's an area that I think still has a lot of promise. I don't see it being used a lot in the quality field today. I've seen some examples, but I think there's a lot of potential there yet to be mined. I guess I hadn't moved ahead. The unstructured data was what I said there. Each of these has a role to play in quality in the right application, but each is also fraught with pitfalls that we have to watch out for. As the old saying goes, every silver lining has a cloud around it. So let's talk about the silver lining first. What are some of the benefits? Well, as I've already said, new methods and algorithms are making things that were previously unthinkable possible for quality professionals and other professionals alike. I know in lots of fields, the ability to do things that we previously thought we just couldn't even try has changed things tremendously, and we're able to tackle bigger problems. Um, so that that's certainly a plus. That also comes with a minus. We'll talk about that. Um, the proliferation of software. There's a lot of commercial software out there to do a lot of these things. Some of it's cost plus. A lot of it's still free. If you've any of you've used the R package, which is all free software, you can do just an amazing number of things with it. It doesn't necessarily have all the pretty interfaces and stuff. That's kind of what you're not paying for, right? But it's incredibly powerful. It's able to solve lots of problems, and so having the software has allowed us to do a lot of things as well. Just the increased awareness across business and government has made the use of advanced techniques much more acceptable. I can remember, as frequent as early or as recently as 15 to 20 years ago, having to justify why I was doing all this statistical gobbledygook, right? To senior executives who said, just give us an answer. We don't want to go through all of this. We don't see the value type of thing. That's changing a lot. The That's been one of the big benefits of having the analytics become so popular. Is I don't think people understand it any better at those levels, to be real honest, but they've seen the benefits at other places, uh, and they're willing to at least sit still and listen to the arguments, and they don't push back as much. So that's been a huge benefit. And just the heightened demand for analytics professionals means there are a lot more educational opportunities out there. Uh, you can't find a college today that doesn't have some sort of analytics program because everybody jumped on the bandwagon. And so you go out and look at all their catalogs. Almost all of them have uh, certainly an undergraduate specialization. A lot of them have a master's program. Many of them are online and at night and things like that, so that they've seen the opportunity and they're cashing in. All that's good for those of us who are trying to build the skills, want to get better at this. It also builds a much larger pool of colleagues, and I'll talk about that when we get into the section on moving your career forward. But don't overlook or miss out on the opportunity to work with colleagues and learn new things that way. I haven't met too many people that weren't more than happy to share what they know. So as I said, there's always that cloud around the silver lining. There are several pitfalls that the quality professionals need to avoid as well. And probably the biggest one, and this I can't overemphasize this one, failing to understand the context for the data. A very famous saying in the quality profession that data have no meaning without their context. The context being, where did it come from? How was it collected? By whom? All of that, some people might even argue soft stuff underneath the data, that's really critical. I think this has been brought home to roost in no short terms in all the COVID stuff. I mean, we're constantly bombarded with numbers and data, and the first question always in my mind is, so where did this come from? Because it's not uncommon for us to see data or conclusions that are diametrically opposed in some of this stuff, and you have to wonder, well, how is this? How come this group says, this is true, and the other group says not this is true, right? And invariably, it comes down to the context for the data and what are they looking at? How was the analysis done? What were the assumptions? This is critical. This is the starting point for analysis, any analytics, and it's far too often not done correctly, ignored completely. This is a huge stumbling block for folks. Right after that, then, is failing to check the quality and applicability of the data. This is where the software can be a problem, because modern software will take whatever you give it and it will chunk it up and spit it out by and large. There are some sanity checks, especially in things like analysis of variance and stuff like that. It will catch really major mistakes, but the bottom line is, if I were to get everybody on this call's social security number and put it into Excel, it would give me the average, it would give me the standard deviation, it would give me the median. Uh, it has no qualms about that. They're just, 11-digit numbers to Excel. The point being is, it's real easy to generate analysis with bad data, and you don't want to do that. Failing to generate testable hypotheses a priori. This is another place where I see a lot of errors. The laws of statistics haven't been revoked by analytics, and this is where I think the fact that a lot of people that are in analytics today don't have a strong statistics background can be a bit of a problem, because one of the things you learn in statistics is you don't just run through data looking for stuff. You form hypotheses first, then you collect data and you test those hypotheses. A good example of this is, again, I keep coming back to the COVID stuff because it's just really timely. But the FDA is a very strong proponent of testable hypotheses, to the point of, you can run a drug study and you can find something you didn't expect in there that's just amazing. And the FDA's first response will be, that's nice, run another study with that as your hypothesis and show that this didn't happen due to chance alone. It's critical. And a lot of what I say, data diving has its risks. And a lot of today's analytics revolves around folks doing data diving. And you will almost always find some relationships in any random data set. That's just how data behave. And so it's really important to say, this is what we're looking for ahead of time. And now we're gonna run the experiment. We're gonna gather the data, and we're gonna see what we find. That's how you build credibility in your analysis. Failure to perform model verification, i.e., is the model correct? And validation, does it give accurate predictions? And this is really where the real work begins. And remember, back we talked about, even the second definition back from one of the dictionaries talked about using a model. Models are really important and very helpful. Verification is critical. One of the areas I see with models, folks build a model and it seems to give good results, and they don't look at the boundaries, the boundary conditions. And so many models go off the rails on the boundary conditions. And so it's really important. Linear regression is a good example. It's a very fine model, very applicable. But if you collect data in a range from 0 to 10, and you build a model that's got a really great fit, and then you use it to predict something in the range from 100 to 200, that model's got no validity there, because it wasn't built on any data in that range. And so that's a real problem. So verification and validation is really important. And then failing to present the data in an appropriate manner. This is another one where Excel's made us really lazy, I think, and I see some just really bad graphs that Excel made very quickly and with lots of pretty colors to boot, right? So it's important to choose wisely. And finally, failure to use an appropriate technique, and this happens a lot as well. Just because your package will run the analysis doesn't mean it's valid. I see a lot of people using linear regression on discrete data. So the data are 1, 2, 3, 4, 5 from a survey, or 1 to 10, but only integer values. That's not an appropriate use of linear regression. You need to use a technique called logistic regression for that, and it gives a different type of answer. And so it's really important to make sure that your analysis fits your data. So let's talk a little bit more about data presentation, because I think this is a really important area. In fact, it's probably more important than it ever was, because now we're looking at so much more data. It's really important that we be able to communicate. There's a constant need to combat poor data presentation in all of our lives. I just updated this chart in February. This was actually found on CNN's website, and just be clear, I'm not trying to dump on CNN, because everybody out there does this. I can find this on just about this kind of thing on any news site at all. But we get these things that really would be much more appropriate as a 1960s wall hanging than as a way to communicate data. This is the daily deaths and causes by region. This is the deaths one, the causes we would have had to click the other button and stuff. So it's an interesting chart, and clearly things have gone up and come down and gone up again. And so while overall I get some message out of this, what's really going on in North America? Did things really spike so badly there in the January, February timeframe? Or is that because it's sitting on top of something else that spiked? Just as an aside, I have little or no use for stacked bar charts, because they make it impossible to figure out what's really driving the change in any given piece of this chart. Is it that section or the pieces it's sitting on top of? And if I rearrange the order on these, I'll get a different looking picture depending on what order I have it in. That's never a good thing. You never want the way you present it to impact the message. So, we're not going to go into how to fix this necessarily, but the point is there's a lot of bad graphical analysis out there, and you want to not fall into that pit. The easiest way I know to do that is to get familiar with a classic book out there by a guy by the name of Edward Tufte. He's a professor at Yale for many years. I think he's still an adjunct, or still a professor emeritus there. In the book, he's got several books out. This was his first book. I still think it's probably the best one. It's called The Visual Display of Quantitative Information. This is a beautiful book. If you've never read this book, you owe it to yourself to find a copy and spend some time with it. I don't know if it's available electronically, but it's very well printed. It's on excellent paper. The graphics are very, very nice. It feels good in your hands. But it tells you all the things not to do by giving good examples of how to do it. So if you get a chance, read through this. You'll never look at data graphics the same way. If you have read it, read it again, because I've read this book cover to cover at least 4 times, and I still go in there and find things and go, oh yeah, I remember reading that, but I've forgotten it, It's just an amazing wealth of information. So, as a quality professional, what can I do? We've talked about a lot of different things, some good things, some pitfalls, et cetera, et cetera. Well, first and foremost, don't let the analytics buzz intimidate you. And these folks can be intimidating sometimes because they think they discovered something really cool, and it is cool. Don't let me give you the wrong impression. But it's not nearly as new as they'd like to let you believe sometimes. And the quality profession's on solid ground here, as we see from the history we discussed. We've been doing a lot of this stuff the right way for a long time. Doesn't mean that we can't learn new things and move forward. We should always be looking forward to expand our skills and impact. So, I'm always happy to pick up new ideas and new tidbits and new ways of doing things, but I always try to test them against what I already know and asking some of the basic questions to make sure that this isn't something that folks have jumped on the bandwagon and isn't really going to give us the kind of results we need. So I think my recommendation is that there are three basic steps to take here. Secure your foundation. I'm going to talk about each of these in more detail here in just a second. Improve how you communicate with data, and then expand your analytics skills where they have the most impact. So secure your foundation. Make sure you've got command of the traditional set of skills. Now, this was, again, originally tailored for folks in ASQ, so I was talking about specifically the certified quality engineer list. But I know in your field, in things like supply chain management, there are lots of analytical tools there. There is a body of knowledge. A lot of it overlaps. That's one of the reasons we tend to have so much synergy at our sessions, is because there is a lot of overlap here. But if you're a supply chain person, I'm sure there's a body of knowledge out there that you could use as a guidance to make sure you've got the basic skills and the recommended skill set for starting off. Again, if you're primarily focused on quality and you're not certified, these are the four areas that I would say are the most likely candidates for a certification if you're looking to go that direction. All of this, there's plenty of information out on the ASQ.org website. It's easy to find, easy to work through. If you're interested, if you want to talk to someone, I've been a certified quality engineer for over 20 years now. I'd be happy to talk with anyone if they're interested in pursuing something in this area. Second thing, improve how you communicate with data, and that starts with just brush up on your basic presentation skills. I don't know anybody that couldn't improve their presentation skills. I consider myself to be in that same boat. And I'm always looking for ways to do things better and to communicate better. In this day and age when people have very short attention spans, this is critical. If you can't get your message across quickly and convincingly, then you're not going to be successful in making the impact that you need to make. So when it comes to actually presenting your data and your conclusions, always state the conclusion clearly on every chart or graph you present. Don't leave it to the reader to draw his or her own conclusion. It may be blatantly obvious to you looking at the chart what the conclusion is. I can promise you it's not that obvious to the people in the audience. And even more concerning is that some other conclusion that you really weren't looking for them to come to might be what they're making while they're looking at that chart. So it's really important. If you've got a point you're trying to make, then state it clearly. If you don't have a point you're trying to make, then you don't need that chart, right? So spend some time with Tufte's book. I can't beat that horse enough. But and always ask, is this the best way to present these data and results? And get a second opinion whenever possible. I try never to do an important analysis by myself in the dark. It's just too easy, even when you think you know what you're doing and you've done this a lot. It's too easy to overlook things or to not ask what about this question? I always try to get a second opinion whenever possible. It's really important. And of course, if you've got a team involved, you want to make sure they're all on board, right? Use the 3-second test. Lots of studies have shown that you have about 3 seconds when you show a slide to get your message across. And if people are hunting past that time to find the result or the conclusion, then you've missed your mark. Another reason why things like that tapestry from the CNN website just really isn't good is that you can spend 5 minutes just trying to figure out what's going on in there. It's way too late at that point to get a message across, and so things need to be clear, crisp. That's one of the reasons why statistical process control is so powerful. It's because it allows you to get to very clearly make a point and move on to the here's what we're going to do about it step. Avoid clutter and unnecessary use of color. This is another one where Excel is really bad. It will use different colors when there's absolutely no earthly reason to have different colors. Uh, if you have multiple colors in a chart, the colors should have some sort of significance. And so it's really important to make sure you follow that guidance. Also, Tufte's got a concept called the data to ink ratio, and you want that to be as high as possible. So in other words, you want as much data being communicated with as little ink as possible. And he goes to the point of even having things like, saying that the axis lines themselves, not the tick marks, are unnecessary, and you should get rid of them and just have the tick marks and things like that. He's very aggressive on this, and he's got an awful lot of studies to show, controlled uh, laboratory studies to show that people respond better when there's less clutter. So, and then finally, expand your analytical skills. Build on the solid base by adding specific skills that make sense in your field. Uh, and find a mentor. Others have been down the path you're seeking. There's pretty much guaranteed there's nothing you're looking at that somebody else hasn't struggled with in the past. Maybe not in your particular field or in your particular company, but it's pretty unlikely that you're the first person to ever go down this path. And so, finding a mentor to help you with these things can be extremely valuable. I look back at mentors that I've had in the past, and they've made a huge difference in my career. And I like to think that I've made difference in people's careers by being a mentor. So it works both directions, and I recommend both having and being a mentor. So consider expanding your credentials. I talked a little bit about certification in analytics before. There are two groups that I'm aware of right now. One is Informs, and that's the one I hold a certification with. Uh, and the other is the Open Group, which has a certified data scientist certification. And there's links for both of these here as well. Right. So, kind of wind down here. We're getting towards the end of the hour. Uh, as you plan your quality projects, I think it's a couple of things I'd like to leave you with to keep in mind. The first one is be mindful of W. Edwards Deming's 3 questions, and I can still, every time I think about this topic, I can hear his gravelly voice in the background asking these questions because I've seen a number of his seminars that were, recorded and stuff. He's no longer with us, but the first question is, what do you want to accomplish? Figure out your goal ahead of time. Again, this is sort of back to that. Don't just jump in and see, well, I wonder what's in this data. What is it you're trying to do? This is especially important if you're responsible for making improvements and work at a company that's paying you a salary to accomplish things. You need to be on top of things and focused when you start rather than spending a lot of time just kind of milling around looking for a nugget of gold in a large stream. So what do you want to accomplish? By what method? So how are you going to go about it? Uh, Deming had a famous saying. He said, a goal without a method is nonsense, because a goal without a method is just a wish. I wish I had $1 billion, but if I don't have a method for how I might get from where I am today to $1 billion, then it's just a wish. It's fun to talk about, but it has no real value in terms of driving change or improvement. And finally, how will you know? So this is what I want to accomplish. Here's the method I'm going to use to go about it. How will I know if I've gotten there? And this is where it gets down to, what tests am I going to use? What analytical techniques? What sort of significance levels? This is, again, back to the pharmaceuticals and drug discovery type of things. They're required ahead of time to say, we will only accept this, we will only decide this is successful if we reach this certain significance level. And so, and usually with the FDA, that's a 99% significance level. They will make exceptions, but most of the time they want less than one chance out of 100 that you got that result by, random means. So knowing how you will know is really important ahead of time. If you keep these three questions as guiding principles, your quality analytics efforts will have a very high likelihood of success. Uh, I've worked on, just literally hundreds of quality improvement programs in my career, and I can't ever remember one that I would say failed. I can remember some that had more impact than others, but we always made some level of improvement. Sometimes we could have made more had there been more ability to make changes, things like that. But we always found things, and it's because we followed these methods. And as you present your findings, I would encourage you to keep in mind something from another one of the quality legends. It doesn't get much farther up the food chain than Deming and Duran, right? Uh, Duran used to talk about the languages used in the organization. And he said there are basically two languages spoken in an organization. The people at the top of the organization think in terms of money. That's what they're paid to do. The CEO is not paid to figure out whether the IP address for the company web server is set up correctly. He's paid to think about the money and whether or not they're making a profit and a return on investment that will keep investors interested in coming back and things like that. The people at the bottom of the organization think in terms of things. We're paid to think about things like whether the IP addresses are correct and whether the process works and whether the quality is what it needs to be, et cetera, et cetera. Somebody needs to translate between those two people, and it's the role of the people in the middle to translate between those two groups. The more you can facilitate the translation role, the more valuable you will become. It's just that simple. The more you can work across this boundary, and it really is a boundary in most companies, the more valuable you will become, and the more you will accomplish. Quite honestly, because you'll be able to talk to both groups, and that's how you're going to get things done. So, kind of wrap this up. Has the analytics wave changed how we do quality? I would say yes, and I would also say no. Yes, in the sense that we have new tools, new capabilities that can enable us to do our jobs better and faster. But no, in the sense that quality as a profession has always been very analytical, and most of what we know is still valid. And I can't think of any of the techniques we use that have been invalidated by the new analytics findings, and they will keep us focused on the right things. So, with that in mind, I believe that's the last slide. Yeah, I got one more comment here. It says analytics has never been, and nor will it ever be, a panacea. It's a tool that, when used correctly, can help us move forward with confidence. One of the things that I think is important to understand about analytics, and then I will stop talking, is that statistics is all about fighting two mistakes that you can make when you look at data. One is you can assume something is important when it's not, and the other is you can assume something is not important when it really is. And those two mistakes will always exist. And while you could eliminate one or the other, you can never eliminate both. And if you eliminate one, you will maximize the number of times you make the other. So it's really about a balance. And that's what analytics, when it's done well, is finding that balance and making as much progress as possible. So with that, John, I'll hand it back to you. I thank everyone again for attending, and I hope you found this valuable.
Okay. All right. Um, Anybody has any questions or comments, you can unmute yourself Let me see
Yeah,
if I can unmute.
I don't have a hard stop, John. I'm happy to answer questions if folks want to run over. I understand
Yeah,
if folks need to go. I don't have a problem with that either.
yeah. For me, what I found interesting, I found it the last time is, this work crosses boundaries, right? It's not purely in the quality area. Analytics is being used now in the supply chain, and the same rules of the road apply. Uh, Plus the fact that supply chain has always been attached with quality, right? We work hand in glove when it comes to manufacturing.
Oh,
So
absolutely.
team effort
And so,
helps.
and I suspect some of you folks have been on the hot seat the last year plus, right? Because what this COVID thing's done to supply chains has just been a real experience. I'm sure it's not been a fun ride.